So here we're demonstrating a project of DC motor speed and direction controlling with help of PIC microcontroller by providing the input signal from these four control buttons. So two control buttons are used to speed increase and decrease, and these two control buttons are used to change the direction of this DC motor by selecting that whether clockwise or counterclockwise. So the microcontroller will continuously read these four control buttons input, and it will control the direction and speed with help of this L293D motor driver. So L293D is a motor driver which is used to control two DC motors simultaneously along with direction and speed change. So here, we are going to providing the speed controlling signal through the PWM pin of our PIC16F72 microcontroller. This is the black wire, and it was connected at the enable pin of our L293D motor driver, and these two are the output to the DC motor, and these two are the input to the L293D motor driver, and this is the power supply from the adapter section directly to the microcontroller. So as we know that whenever we want to control the speed of a DC motor, then we need to control the on time and off time. So let us see, if we increase the on time, then the average voltage from the microcontroller to the DC motor through this L293D motor driver will be increased. So whether it is 0 to 5 volts. So I am changing the on time, then the microcontroller will provide the average voltage of 0 to 5 volts. Then the DC motor will rotate with high speed whenever you get the more on time, less on time and more off time, then the DC motor rotation will with the low speed. At the same time, direction change also will be happen with help of the L293D motor driver, as it has the two H-bridge circuits inside the L293D motor driver. So whenever we are providing 0 1 clockwise, 1 0 counterclockwise, 0 0 switch off the supply to the motor. So let us see the module wise explanation. We are providing 230 volts input to this adapter, and which will provide the 5 volts constant regulated power supply to our whole circuitry. So as the whole circuit will work under the 5 volts, as we are using 5 volt DC motor also. And next, so once we provide the 5 volts power supply, so there will be one capacitor. Whenever we provided the regulated power supply, there is a chance of ripples in the regulated power supply also after regulation, then that will be neutralized with help of this 1000 microfarad capacitor. And this one is the restart switch. So whenever the system is not responding properly, then just provide this switch to restart the system. And next, there are two LEDs. One is the power LED indication, and there is a program LED indication. So example, whenever we are increasing the speed, just hold the switch, this will blinks as it's showing the speed is increasing, and whenever the light blinking stops, it shows us that is the dead limit for the increasing as well as same decrement also. So coming to the PWM pin, it's going to be the C2 pin of our microcontroller, and these these two buttons at A0 A1, these two buttons at B0 B1, and L293D direction pins are C6 C7. And coming to on this motherboard, there we can see one steel plated one. This one is a crystal oscillator of 20 megahertz, so which will provide the 20 mega pulses per second. So the main purpose of this crystal oscillator is whenever we are executing a project, we need to provide some instructions inside a microcontroller. So the instructions will be executed based on the clock pulse input, the speed of the instruction execution. So for example, the instructions are like reading button 1, button 2, button 3, button 4, control the direction of the pin and speed of the DC motor. So these are the instructions. Reading the control button 1 inputs. So 1 clock pulse, read 1. Second clock pulse, read 2. Third clock pulse, read 3. So like this, these instructions will be executed whenever we provide the clock pulse. So like this, the system will execute 20 mega instructions in 1 second, as we are providing 20 mega clock pulse frequency from this crystal oscillator. So this is all about the each and every module. So there we can see 4 resistors. So each push button come with a pull up resistor. So whenever you press this, it will provide the ground 0 to the microcontroller respect pin, and when we release that with the help of this pull up resistor, it's in high. So if it doesn't place any resistor here, the particular pin in floating nothing but there is no input, so it will take garbage value, then the system will malfunctions. So let us see the demonstration. Just provide the power supply to this, and there we can see the light is on and off 2 times. And after that I want to increase the speed now. So before that we need to set the direction clockwise, and then hold it. We can see the light is blinking, right? So see, and press it and hold till maximum speed, right? Now the light is not like responding, means we have reached the maximum speed. At the same time decrement also, so we have reached the dead end. After that the light stop blinking. So as we can see, it's not rotating now because it needs some current. The particular current will be get whenever it reaches some certain voltage, and now it's clockwise and counterclockwise. So I want to decrease the speed, right? Again clockwise and counterclockwise. So these are read by the PIC microcontroller, and the instructions are used to set the speed and direction of the DC motor. Thank you.